Okay, so the following is another test of geospatial modeling. You can see here the Google Maps from the local area, and there's a particular area I'm interested in, and I did some modeling. Is here at the local part. Just moving the map a bit over, and you can already see here the air. This is a recording from this morning. This is outside area at a place called the Eastbrook and Discovery Center. You can say here, you can see the Google map and overlaid the orthophoto that is taken. It's actually a composite picture of, I think it was 28 individual HD pictures, and you can see I can overlay this either with a plant health analysis, and there's different models available, different algorithms that can be applied for the purpose of different coloration. And also I can apply a surface model, which is probably more interesting when I overlay this. So it gives you a good idea of different levels of vegetation. You can see here the trees are dark colored green and dark red orange, whereas grass and the surrounding area is blue, and you could probably argue this might be also quite similar to what the temperature looks like. So airs like this would be cooler, whereas airs like these ones would be slightly warmer. Now what I then do is I switch to the model representation, and that will take a moment to calculate and build. Since I'm using do this different types of models, so for instance you can use a model to buildings, other 3D objects use high definition. It's actually done that, so that model pictures, and you can see it going back and forth between the cloud and building up. Now you can see the borders around individual items, and the graphical representation is getting stronger now. So I'm just waiting until it's done this. So it's done that, and I'm also showing that has worked. And what I can now do is I can zoom in, and I can also move this around. You get already an idea what this looks like, because it's kind of 3D. What we're missing at the moment is the tree have flown either at a slight height. If this was taken at 25 meters and with quite a bit of wind, then you would have tree trunks as well. But you can move, if you like, through this model by turning it around, and you get a bit of an idea of the dimensions and the representation against the landscape. Now one interesting thing I wanted to show you as well is if I turn this back here, what I also can do is I can do the following. So taken almost from top, and what I can do is I can overlay with measurements. For instance, I can do a point measurement, and I could say, okay, I want to understand what is the distance between this path here and this middle bit in the area. You can see that's 11 almost. Now when I remove this, I can also do area specific measurements. Let's move this, and I can say, okay, let's measure the whole area out. So I can start here, and I want to understand if I go here and here, and you also get the individual measurements between all those points. And I go back here, then you would see in the middle that is 742.7 square meters, and you can see the spread of this area. So it's around 40 meters each, and at top it's almost 11 meters, which quite ends up infrastructure, buildings, areas of deforestation, plant growth, infestation. We've take here that has got some crassia infestation, and I measure that out, and the surface area that is covered by that. So I remove that again, and you can take different angles. You can even, if you wanted to, and if you have building, do a volume measurement of a whole area. Obviously, if you do that, you're probably better off doing it when you got the 3D representation. In a nutshell, is the representation, both at 2D level and 3D level, of this area. And I hope you found this brief presentation of interest. Thank you very much.